Page 27. Solving rational equations and inequalities. So you want to set up the fractions and make them just one on each side. Distribute and combine like terms. Cross multiply. Bring everything to one side. Factor, solve. And then check for extraneous solutions and exclude values like wholes and vertical asymptotes. Remember, to check for extraneous solutions, you plug in the answers that you find into the original and see if it gives you a true statement or a false statement. It'll most likely give you a false statement if it gives you something like divide by 0, for example. Let's review what the names of each of these symbols are. This one right here is the equal sign. This was less than, greater than, not equal. Basically, if you ever have a sign with a slash through it, it means not whatever that sign means. This was less than equal to. This was greater than equal to. What happens when you divide each side of an inequality by a negative number? That's when the inequality sign flips. So less than becomes greater than, and vice versa. Let's look at some of these. Solve each equation. Remember to check for extraneous solutions. Let's look at this one. We have 2 over x equals 6 over x squared plus x plus 4 over x squared. First, we will make this a same fraction. They already have common denominators, so we could just add straight across. So we have 6 plus 4, that's 10, and then x, it's just x. From there, we're going to cross multiply. You have 2x squared equals x squared plus 10x. Okay, let's bring everything to one side. So then we have 1x squared minus 10x equals 0. Let's factor this. They both have an x. And then what's left inside is x minus 10. So x equals 0 or x equals 10. Now, 0 is an excluded value. It's extraneous because if you put it in the original, you would get undefined. 10, if we plug that into the original, we get 2 over 10 equals 6 over 100 plus 14 over 100. Well, let's multiply these by 10 each to get 100. So 20 over 100. Does that equal 14 plus 6 over 100? Yes. So that's a real solution. Let's look at another one. Let's look at this one. We have 1 over n plus 1 is less than or equal to 1 over 3n plus 3 minus 6, n minus 6 over n plus 1. Well, 3n plus 3 can be factored to have 3 parentheses n plus 1. To get the same thing for this one, we're just going to multiply these by 3. And then, of course, these by 1. Okay, so from there, we have 1 over n plus 1 is less than or equal to 1 over 3 parentheses n plus 1 minus 3n minus 18 all over 3 parentheses n plus 1. Now we want to distribute that negative into each numerator term. So then we have 1 over n plus 1 is less than or equal to 1 minus 3n plus 18 all over 3 parentheses n plus 1. Okay, combine like terms. And we're going to cross multiply these. So then we have 3 parentheses n plus 1 less than or equal to n plus 1 times negative 3n plus 19. Well, the n plus 1s could just be divided out and canceled. You'd also have an excluded value there. N can't equal negative 1. So then we have 3 less than or equal to negative 3n plus 19. Okay, let's add 3n to the other side, just so that we can have everything be positive. And subtract 3 to the other side. So then we got 3n is less than or equal to 16. From there, divide each side by 3. So n is less than or equal to 16 thirds. From the original problem, the original inequality, that is not an excluded value. So that should be real here. If you were to plug it in with the calculator, you should get a true statement. Let's plug it into the calculator, see what we get. So when we plug this into the calculator with 16 thirds, let's see what we get. It's true, so that's a true statement. So yes, that is a real solution. Let's look at one more on this page. We have 7n squared for these. So let's multiply these by 7n. So then we have 1 over 7n is greater than or equal to 1 over 7n squared. And then we're also going to add 7n up here. We have an excluded value of n can't equal 0. Because you can't have 0 in the denominator. Okay, cross multiply. So we have 7n squared is greater than or equal to 7n times 1 plus 7n. Well, one of those 7n's, they can divide that out. And then you're left with n is greater than or equal to 1 plus 7n. Okay, let's subtract n. We get 0 is greater than or equal to 1 plus 6n. Let's subtract 1 to each side. Negative 1 is greater than or equal to 6n. Divide each side by 6. So negative 1/6 is greater than or equal to n. That's basically saying that n has to be less than or equal to negative 1/6. And your excluded value is not even in this domain, so it doesn't affect the answer. Try the rest of these problems on this page on your own, and then move on to the word problems.